Alright, so this is where we left off in 7.2 in the first video. And just continuing on with the distributive property, So as we do this with rational exponents, just make sure that you're aware that you are multiplying with the same base means that you add the exponents. And hopefully you can see where I got all these values. 3/5 happens twice, 1/3 here, 2 here, and then you just need the same denominator. So I'm looking at the denominator being 15, because 5 times 3 is 15. And if it helps, you can even rewrite it like right here, like change 5 to be 15. We have to multiply by 3, so this has to be 9. I hope you agree that 9/15 reduces to 3/5 if you divide top and bottom by 3. In the same manner, then, make this 15, so this 1 would be 5, and 5/15 reduces to 1/3, multiplying top and bottom by 5. So 9 plus 5 would be 14, and then just switching colors. I would probably just change this to be a denominator of 5. I hope you're aware that 10/5 is equal to 2. Try to change colors, but that's okay. 3 plus 10 would be 13/5. There you go. And then over here, just you can practice with FOILing. And x to the 1/2 times x to the 1/2. Remember, you add your exponents. Well, 1/2 plus 1/2 would be just 1. And that should make sense, because if you were to say, okay, x to the 1/2 plus 1/2, or think of it as a square root of x times the square root of x is equal to just x, which is the same thing as x to the first. Anyway, that's over explaining it. And then on the outside terms, you have negative 2 x to the 1/2. Inside is plus 6 to the 1/2, x to the 1/2. So that's plus 4 x to the 1/2. And then 6 times negative 2 is negative 12. If you're confused by any of that, I would encourage you to actually write out the FOIL terms. But if you're still confused, write it down, bring questions to class, and I would love to answer them. Alright, so this next one's a little bit more complicated because what we're asked to do is to factor x to the negative 1/2 out. So basically what that means is that we're going to take this negative power outside, and what are we left with? So it's pretty complicated. So at least that's my opinion. So basically what it boils down to is by factoring out negative 1/5, the question then is, well, what's left over? So there's two ways of doing this. You can ask yourself what number plus negative 1/5 will give you negative 1/2. Probably a better way of doing it, though, is to take that negative 1/2, because we're factoring out, we're dividing. Basically what I'm saying is we subtract off negative 1/5. And that's what goes in here. So we probably want to get the same denominator. So make it out of 10, so negative 5/10, and then plus 2/10. And you would get negative 3/10. And I hope you would agree that adding these together, negative 1/5 plus negative 3/10 is negative 1/2. And then same thing is we have that minus 7, because that's not really going anywhere. But the same process, take that 5/2, and we're going to subtract off negative 1/5. Maybe I should over-explain this as well, because really what we're doing by factoring something out is we're dividing. So really what I'm doing is taking that x to the 5/2 divided by x to the 1/5, which is equal to my work right here. I hope that makes sense. If not, again, bring your questions, and hopefully I can answer them. So we get the same denominator to the 10th power. The denominator needs to be 10, so 2 times 5, so 5 times 5 is 25. And then change that to be plus 2/10. 1/5 is 2/10. So that would be 27/10. And if you were to do negative 1/5 plus 27/10, it would reduce to 5/2. So we're good there. Moving forward on the next one, again, feel free to write down any questions you might have, and we can answer them. So what we're doing with exercise 7, example 7, is getting you to just use rational exponents. So it's just working backwards. Remember, the index is the denominator of your power. By the way, rational exponents are just fractions. I've probably said it early in the first semester. But then they also want you to simplify that. So 3/9 reduces to 1/3. And that's the answer we want. Looking at the next one, might seem pretty complicated, but you can reduce this. So for instance, this is the same thing as 36 to the 1/4 power. And I don't know how many of you would think about doing this, but 36 is the same thing as 6 squared. So 36 is being replaced by 6 squared. That 1/4 is still there, but if you take a power to a power, remember you can multiply that. So that's the same thing as 2 times 1/4 is 1/2. That's the answer the book wants. Now the book might also rewrite it as the square root of 6, which you could verify is correct if I were to pull up a calculator and just type in math, the 4th root of 36. But notice if I just typed in the square root of 6, I get the same exact decimal. So the calculator won't tell you that the 4th root of 36 equals the square root of 6, but once you figure that out, you can double check by typing it in and seeing that you get the same exact decimal, which I think is very helpful, but you might disagree. On this last one, though, all they're looking for you to do is rewrite it as a to the 4/8 power times b to the 2/8 power. Remember, the index is the denominator, and then reduce those fractions. 4/8 reduces to 1/2, and 2/8 reduces to 1/4. That's what they want there. And then our last problem is getting you to do a little bit more math, which is, I hope it's not that bad. But there's multiplication in here, and they want you to write it as a single radical. So if you were to rewrite this, first of all, as x to the 1/3 times x to the 1/4, remember that means that you add your exponents. So then from there, you got to get the same denominator. So the common denominator would be 12. Let's see, 1/3 would be 4/12. 4/12 reduces to 1/3. Again, I'm multiplying top and bottom by 4. Over here, I'm multiplying top and bottom by 3. So 1/4 is equal to 3/12. And now I can add my numerators. The denominator stays the same. That would be x to the 7/12. But then there's one more step they want you to do, and that is rewrite it as a radical, as a single radical. This is the same thing as the 12th root of x to the 7th. And then the next problem is really the same work, just kind of getting you to understand we have y to the 1/3. Remember, when you divide, as a division, you subtract your exponents. And if you get the same denominators, just like I did before, that would be 15. It would be 5/15 minus 3/15, which would give me 2/15. But again, they want you to rewrite as the 15th root of y squared, and that's the answer we want. Now, this last one might not be much to do because the bases are not the same. Notice that these two bases were the same. So what I'm talking about is 5 to the 1/3 times 3 to the 1/2. Well, the bases aren't the same, so we cannot combine, remember the bases have to be the same in order to add the exponents. And the index has to be the same if you were to put them together. So really, this is nothing to do. This cannot be simplified. So I'm sure the book tries to confuse you a few times with that as well. Notice this is a pretty lengthy assignment, but some of the questions that happen very, very quickly. Yeah, work through it. Let me know if you have any questions, and bring your questions to class. Love to answer them.